charging continuously takes 6 to 8 hours rated power, and this loads the system. I started playing with the electricity at 8th standard.
1,800 cars were sold next year, 3,600 cars. Next year, because of COVID, 3,400, and now it is coming to 7,000, 15,000, growing at 100%. Hi guys, this is Reva.
Hi, this is Sugun Kumar.
So guys, we have Sugun today at a podcast, and Sugun handles the operations and safety at Kazam. So Kazam obviously is a enabler for charge point operators, and a lot of electrical work goes around whenever somebody is trying to establish a charge point business. So Sugun has been taking care of all these operations and safety related aspects for us, and he comes with a lot of experience in the electrical domain. So welcome, Sugun.
Thank you.
So for starters, if you can explain how your journey has been up till now, not just in Kazam, but starting of your career, and how did you finally ended up in this place?
Yeah. So starting from very early stage, I started playing with the electricity at 8th standard. I did my house wiring at 8th standard. Then I don't know, somehow I was very much interested with electrical technology or electronics. And then obviously my interest pushed me to take up a diploma in electrical electronics. And after that I continued, I completed my graduation in same electrical domain. And immediate after my graduation, so I started my career in cement industry. Yeah, they're a very old company, very strong company, which has very wide where I got very much exposure to electrical systems. Instrumentation or HT motors, each capacity of 1.6 megawatt.
So I think you need to tell the users what HT means.
Yeah, okay. So there I got
HT means high tension, right?
Yeah, it's high tension.
So whenever electricity comes at our house or any place, it is either high tension or low tension. Right?
Yes, we normally use low tension power system, that is 415 or 230 volt. And whereas industries works at high tension, that is 11 kV, 166 kV, 132 kV. Yeah. So after my initial career in Andhra Cement for 2 years, after I joined with Grasim Cement, that is now Ultratech Cement. There also I worked in instrumentation and electrical. So there I got very much advanced system exposure. And then with that experience, I joined with a petroleum company called Petronet MHB Limited. There my real growth in electrical system happened with my initial learnings at cement industry. So in Petronet MHB Limited, our prime importance is safety. Safety in terms of systems as well as asset handling.
So what was this company doing?
Company deals with petroleum product transportation. Company has a 362 kilometer pipeline, underground pipeline, from Mangalore to Bangalore.
So laying down the pipeline and operation, and obviously managing those pipelines.
Yeah, we operate and maintain the pipeline. It is already existing pipeline. So we handle a very hazardous volatile petroleum product, and it needs a very much high standard of safety. So almost 12 years I worked with Petronet MHB Limited, and my total experience counts to 16 years now. And my curiosity towards electricity developed interest on EV as well. In 2000 when Reva I launched, I was very excited and curious to know about the vehicles, to learn about the electrical vehicles. And then I got chance to witness Reva I in 2008, and I was amazed. So a very teeny car, and still it is functional.
Reva is now called E2O.
Yeah.
I guess it's
Yes.
acquired by Mahindra.
Mahindra, and later it was renamed as E2O. And I uh, tried to purchase E2O in 2015, but unfortunately my pocket not allowed me at that time. But fortunately, 2 years back I purchased E2O. Now I am currently driving E2O for my daily commuting.
Okay.
Yeah, this was the interest on EV, and I have two-wheeler, four-wheeler, and my business also runs on three-wheeler EVs. So this is the my attachment with EV or interest towards EV.
Yeah, I mean, I think Reva was the first model that was launched in India, I believe, in the electric vehicle
Yes.
domain, in a B2C segment, I believe. And I also feel sometimes that Reva does not get its due credit.
Right.
Maybe the time was, it was ahead of its time, you can say.
Yes, it is very immature market for that time, but product was very well built product.
Right. And with Reva kind of also makes me think that, we say that the EV revolution has first come in West and then here, but I really admire Reva and founder of Reva and then founder of Reva, and now obviously it is part of Mahindra. And I think that ideology of Mahindra kind of displayed their tendency to move towards Mahindra other models, like we have Verito now.
Yeah.
So I think, and now obviously the new range of Mahindra has come. This is called the B Electric B, and so 5 cars have been launched in that. So the 3 of them are actually modified version of XUV 500, and 2 of them are of the new series. So and obviously the dominant players right now in India are obviously Tata and Mahindra. So this E2O thing, I think, kind of built this electric DNA within Mahindra's team, and though Tata Nexon came, I think, and just acquired the market in a pretty big way.
Right.
But definitely, I believe Tata and Mahindra are the 2 players which have significant market share in this below 30 lakh car segment.
Yeah, any common car user can afford these Tata or Mahindra built cars.
So, and coming to the work that you're doing in Kazam, so obviously now around electric vehicles we see. So, in an electric vehicle, first is obviously the electrical part is inside the electric vehicle. There is a battery, there is a battery management system, there is electric motor. That is one, and then there is a charging mechanism, which can be a converter or a charger. Then there is a EVSC, which we call as charge point or sometimes charging stations.
Yes.
And then there is distribution box at the facility, or it can be just a meter. So there is whole in this chain where the electricity is coming and finally coming to the battery, there are a lot of touch points.
Right.
Battery, BMS, converter, connector, then EVSC, and then finally the distribution box and grid. So and there has been concern around safety recently in the EV ecosystem.
Right.
So what do you feel is that is important at each point, or is the most susceptible point of failure at any in the safety line of this current flow? Because in petrol car, you don't have to think much. You just have to make sure that it doesn't touches anything hot, I believe. So, what is your take on from a safety angle to the EV ecosystem? You have been driving EV also, so I believe, and you are here present with us today. So I believe. So yeah, from that perspective, what do you feel is the your take on safety ecosystem?
Yeah. So coming to hazard with the electric vehicle or electricity. is very significant when coming to electric vehicle. Whereas hazard with the petrol or fossil fuel is very less and it is preventable or it is controllable.
Right.
Whereas coming to hazard with the electric vehicle, the safety plays first place. So safety, vehicle utilization and safety at vehicle charging.
Right.
So these two are the important aspects to be looked in.
Correct.
Yeah. Electric vehicle safety aspect obviously will be taken care by OEMs, and that is where this BMS, that is where BMS and vehicle electrical systems are taken care.
Alright.
And
So, but the cell battery level, I mean, the quality of batteries, I mean, how much role does that play, and what parameters the end user should be looking at, or ultimately it's OEM who is deciding which batteries to be put in.
Exactly. OEM takes care about cell quality, rating of the cell, everything will be as per the electric battery operated vehicle.
Alright.
So that there are categories. Battery operated vehicle needs different cells and backup requirement needs different cells.
Right.
So now coming to user perspective, we have to think about how good that vehicle getting system, integrated system, that is with charger, BMS, battery cells. But user perspective is about charger, not about vehicle system. Vehicle system already taken care by the OEM. And that is as per the stipulated guidelines.
Guideline by the, I guess, various
automotive
regulatory bodies.
Yeah.
And now, so you're saying that, okay, now that I have purchased a vehicle, so I can charge it in multiple places. I can charge it at a DC fast charger. I can charge it at home with a charge point. I can charge it at home without charge point at a normal 3-pin socket.
Okay.
So are all these three ways of charging equivalently safe, or should we avoid charging at home with 3-pin socket, or what's your take on this?
Yeah, obviously we can charge at home, but there is a pre-request. There is a consciousness.
Alright.
So without consciousness or without pre-request, if you charge at home, obviously it brings risk and it leads to a hazard. Why? Because normal ordinary sockets are designed for home appliances, not for EV charging. EV charging demands continuous high loads, whereas domestic appliances need short time, low loads.
But is running an air conditioner in my home and charging EV, are they different, or are they similar?
There is a lot of difference.
Alright.
Yeah, let's say air conditioner, when we set a particular temperature, it meets that temperature level and cuts off.
Right.
And again it gives some cooling time.
Right.
And then again it starts.
Right.
So it's like start-stop mechanism where that loading condition never hammers the system. Whereas EV charging continuously takes 6 to 8 hours continuous rated power, and this loads the system. So where there is a weak points and joints and loose connections leads to temperature growth and it leads to consequent problems.
Alright. So you would suggest that, so let's say I want to charge at my home, so I should just make sure that first my electrical wiring and everything is perfect, my load limit is well sanctioned places.
Right.
But won't the BMS battery management system take care of these things like cut off on and off? Because when we see in our software few charging profiles, few of the vehicles just charge continuously at a particular current, some of them charge initially at high and then at low. And interestingly, few of the vehicles have been charging in this fashion that in a rectangular graph section,
Pulsating.
way. So I feel that maybe BMS comes into picture and tries to take care of things.
Yeah, well, actually BMS takes care about cell or battery,
Alright.
not about the source.
Okay.
BMS thinks about battery, how to charge, how much charge, and that will be taken care by BMS.
Okay.
Whereas source related aspects taken care by the technical EVSE, we call it as EV charging point.
Charging point.
Yeah.
So you're saying that BMS will try to protect the cell's health and it will try to equate the current across the small cells, or what you call it, the bus charging, the sections of cells, individual cells, so that none of them
Battery cells.
yeah. But then we're coming to the source side, and then something that is controlling the current to the vehicle is where the charge point comes into picture. So how does the charge point, if I do go for a charge point, how does it really protects my vehicle, or prevents me from any hazard?
Protection or safety with respect to electrical utilization comes in three directions. One is earthing system, and second one is overload protection, and third one is insulation and conductor size.
Okay.
So these three parameters these three parameters are the vital aspects to be taken care.
Okay.
Yeah. Coming to how my electrical charge point products or gives this safety. One is my charge point ensures earth availability or earth continuity, and my charge point ensures overloading condition, and my charge point monitors insulation, and my charge point monitors conductor insulation.
So conductor insulation is prevention of any leakage current?
Yes, leakage current. When there is insulation failure, current leakage will happen, and that will be detected and prevented.
Alright. And so earthing fault, I understood that there is no earthing from the source side, and vehicle will obviously in order to protect the user as well. And then overload protection is saying if there is a spike in current or above or beyond a particular limit, so it will limit the usage. Either it will shut down or it will probably lower down the current if it's a smart DC charge point.
Yeah, there are two types of chargers functionally, mode 2 and mode 3. Mode 2 charger will not have any communication with the vehicle, and it will cut off on overload condition. Whereas mode 3 charger will have communication with the vehicle, and it will understand that condition and it controls the output load.
Okay. Cool. So let's say I'm going for my house socket itself. So but there is obviously circuit breaker, MCBs and fuse also. So will they not be sufficient to protect against any overload or overcurrent?
Yeah, household distribution system will have MCBs and fuses, obviously, but that are combined to the total aggregate load of the household. Whereas EV load will have a different loading pattern, and this need to be protected from dedicated sub-circuit. We cannot club EV load with the household load conditions.
You're saying if it's on, it shuts down everything, and probably even if I again put it back on, it will again go down. So if I can handle that load at that particular source point for dedicated for EV charging, that's much better.
Yes, that is the as per regulations also. EV charging loads should be connected with sub-circuit. We cannot club the circuit with the common common loads of the household.
All right. So cool. And now coming to, let us say, Indian let's say driving behavior itself. I mean, there are many, so to speak, you can say hypothesis, or somebody can call it myth, somebody can call it just guess. But Indian climatic conditions are relatively hotter, and obviously the batteries that are either being imported or assembled may have been made for different climatic conditions. So, when it comes to driving behavior of the EV driver, is there anything that EV driver needs to make sure he can, drive and charge in any fashion possible? For example, I met some person and they said that, what we want is that when our EV driver finally comes back, they wanted a 10-minute rest period before they start charging. Now, there is no way to determine whether this is actually contributing to any of the safety parameter. Is just a guesswork here, that, or you can just start charging right at the moment you have just come from a long journey. So, any particular insight you have in this area?
Yeah, I'll divide this in two parts. One is battery aspect. Batteries are designed at different country and different environment conditions that are being imported to India, and Indian environment conditions are different. Yeah, I agree on that. And these battery cells need to be redesigned to Indian environment conditions, and then we can say batteries are safe to use in Indian weather conditions. Yeah. Coming to charging immediate after utilization.
Yeah.
Here one key aspect to be understood is cell gets heats up both in charging condition and discharging conditions.
Okay.
So when I use EV for driving, obviously cell gets heats up, and at that same heat, if I go for charging, it's a reverse process in battery, and it again accelerates that existing temperature, and cell temperature will increase. So we know that electrical system will not work efficiently under high temperature conditions.
Right. So using that, basic logic dictates that if you have come from long journey, you can wait either to charge, or maybe you should have a provision in your EVSC that it has some sleep wake up time.
Right.
Or probably even BMS may have that mechanism that it has some wake up time,
Right.
In order to start the current.
Yeah, advanced BMS system has this feature. They monitor cell temperature, and then they allow both cycles, charging as well as discharging.
Right.
So let's say I'm discharging battery and battery temperature increases beyond certain limit, which is unsafe for the battery. Then BMS cut off output.
So that's what I would like to tell the audience as well, that battery management system is a very integral part of the whole this chain of charging, that it controls, because it also has advanced, like Sugun said, advanced BMS have temperature sensor. So the BMS itself will cut down or stop the current at any particular point it feels that is there. Because I think in EVs also, in cars also, sometimes if it's overrated, it will show a message that it's already beyond a certain amount of temperature. But apart from that, now that you are a EV user, so like how is there is obviously there is an early adoption involved when you bought an EV. So I would say you bought an EV in 2018, I believe.
Yeah, 2019.
Okay, so but that's still early from a car market in India, because I remember when we were starting the company 2019, 1800 cars were sold. Next year 3600 cars. Next year, because of COVID, 3400, and now it is coming to 7000, 15,000, growing at 100% and 200% rate. So how has your experience been in terms of finding the charge points in case ever your EV ran out of battery? Have you experienced that range anxiety in actual?
Yeah, true. EV user definitely will have range anxiety because lack of infrastructure. That is true. And 2019, when I took my vehicle on road, I'm clueless and I am uh, uh, range anxiety. So I'm every time I used to drive with preparation and calculations.
Right.
So how much distance I have to travel, and I have to limit my travel also so many times.
Alright.
So this planning needs, and if you go unplanned with the EV, then you'll be middle of the road.
So, but do you feel that the things have changed coming to 2022? Is there now a better infrastructure in place, and somebody buying an EV can now because already see the range is also increasing for the upcoming vehicles. If you see Tata Nexon EV claim range is 312 kilometers.
Right.
I think it's higher for Tata Nexon EV plus Max. Hyundai Kona MZ is a little costly car, but they also claim around 400 kilometers.
Yeah.
So now, I mean, it's pretty good range. I would say it's not sufficient. So, but it's pretty good range. So at the same time, the batteries have become compact and are storing more range. And also, there has been a lot of measures from the government, measures from the private companies to increase the charging infrastructure. So now as a user, do you find it different? Is that anxiety still there, or is it you feel it is resolved to a certain level?
Yeah, after central government schemes like FAME 1, FAME 2, there is a lot of change. So both in terms of vehicles availability in market as well as charging infrastructure. So let's say in 2019 or 20, rarely I used to see 100 charge points in Bangalore city. And today, 2022, if I see, it is more than 3,000. It is like that condition. So fortunately, Kazam playing vital role, and we have 1,000 plus in Bangalore and 4,000 plus across India. This is the change happened in a EV ecosystem, and future will be very convenient for the EV user. There won't be any range anxiety issue. Wherever any corner you can find EV charging facility.
What do you feel the charging behavior will be like? Where maximum people will be charging?
Charging pattern, normal user charges at home only. Why? Because he spends minimum 8 hours at home, and that is sufficient for EV charging.
Right.
And workplace is another place where most of the time spent in a day, and that is also a possible charging point. And coming to commuters, so they can charge at any fast charge point, that is called en route charging. So that are available currently across all petrol pumps and major food chains. So I don't feel 300 or 400 range is less for the day. Means 2022 we can.
I guess intercity is fine. When it comes to intercity travel, it might be you may need to plan your pit stops.
Right.
But I believe intracity is definitely sorted somewhat.
You are right. Intracity, exactly every nook and corner you can find EV charging point, and there is no issue for the. And typically, any EV user inside city won't travel beyond 100 or 150 at most.
Right. So now coming to one more point that is the conversation that has been going around in the industry, that batteries life cycle. Now batteries life cycle, does it get impacted by the fact that I am using DC charging, fast charging, or AC slow charging? Does it contributes or deteriorates or increases in any way my battery life cycle, or is it use whatever you want?
Yeah. So with my knowledge, I can say DC fast charging impacts battery performance as of today technology. and uh, slow charge always gives that designed life of the cell or life of the battery.
But is the impact too high, or is it like, I know they may be not, we may not have a number key that this by this percentage the vehicle the battery life is reduced, but is it is it a bigger impact, or is it like, because people may want to charge their vehicles faster. Let's say in my society I have a DC fast charger and I have an AC slow charger.
Yeah.
Or in your society you had both. Anyways, your vehicle was parked for, let's say, 8 to 12 hours. So which one would you go for?
Yeah, here it is obvious that when I have sufficient time and which gives advantage of good battery performance, then I'll go with slow charging. And when I'm in rush, I have very limited time and I can compromise on performance and I can charge on DC charge. So it's like case to case and condition based. So we cannot say that fast charging only the option or DC for slow charging only the option. It's based on the user requirements. So, but coming to long run, AC fast charging will be the winner for the battery performance.
But coming to the fleet segment, so for example, someone might be planning to do a business of becoming a charge point operator. I may be going for 100 charge point at a place, or I may be going for 10 charge points. So what do you think is the checklist that I should have? Okay, good that you're going for this many charge point, but any basic checklist that I should have in mind?
A charge point operator needs sufficient real estate and power source, and that are the basic requirements. After that, any individual or entity can start charge point, and to build charge point there are certain regulations issued by Central Electricity Authority as well as Regional Electricity Authority, and safety bodies issue different regulations, and these are to be followed to build any charging station. So coming to building building a charge point involves proper planning. To construct a charging point, basically sufficient real estate and power source required. And power source, let's say Bescom connection here, if it is here in Bangalore or Karnataka, Bescom will sanction certain load, and depending upon the loading requirement, they decide at what voltage to be that service to be given. So for any charging station up to 150 kilowatt, they provide LT supply, low tension supply, and with dedicated transformer. And with these minimum requirements, dedicated transformer, any charging station can be started. And coming to planning, there are safety requirements in terms of electrical as well as operations. So electrical safety regulations, there is a requirement of overload protection at power distribution level as well as charger level, that is called sub-circuit or end circuit. So every charge point should have a dedicated overload protection, and there should not be any looping of power from one charge point to another charge point.
Not very initiated in this. So what's the difference, like overload, heavy current, and are you saying that this is voltage surge and this is current, or
surge is a different phenomena and overload is different phenomena. Overloading is the excess current drawn from a point, and surge is the fluctuation from the source end.
all right?
Yeah.
So even if there is no load at this point, but there can be still surge.
Surge, exactly. So surges can be surges may be caused due to third party influences, whereas overloading condition happens purely own loading conditions.
Okay. Okay. And let's say if somebody is going to build his charging station, should he go for a separate transformer or not? Like, is that what's the thumb rule there?
Yeah. This factor decided by the distribution company, power distribution company. Basically, they decide up to what power level transformer need to be provided from the service provider and where user to be source user to be provided.
So what is that limit in Bangalore?
Yeah, BESCOM and across India, if we see up to 30 kilowatt, service provider will provide. And to be specific to BESCOM, if we say 35 kilowatt, they can provide from service line. And beyond 35, they ask user to provide transformer, dedicated transformer.
And where does high tension and low tension line come into picture?
Yeah, when total load requirement crosses 150 kilowatt, then high tension service line required. And below 150, it is LT based connection.
So yeah, I mean, there's pretty good thumb rule that beyond 30 kilowatt, mostly you should go for separate transformer. Beyond 150 kilowatt load, you will go for high tension line. Is the electricity charges high for high tension line?
No, not high, but demand charges will be high. But whereas total energy charges, if you see, both will be same.
Okay, all right, cool. So yeah, that's great then. And apart from that, any other safety parameters a charge point operator or a charging station manager should take care of in terms of preventive or mechanisms? Yeah.
Yes, preventive maintenance plays vital role to ensure safety. So getting up or putting a system will not be a sufficient for safety. Putting a safe system will not be a sufficient. Maintenance required. Charge points need maintenance both in terms of efficiency and safety. So electrical system switchgear needs maintenance. Termination may get loosened and cable may get insulation failure, and these are all need to be identified before incident.
They should be regularly checked.
This is where preventive maintenance involves. So preventive maintenance will ensure the failure, will ensure to prevent failure.
Alright. And I guess, Kazam, you have made a very strong point across the teams that the fire extinguisher that should be kept should be foam based and not CO2 based. Before this, even I didn't know that there are this type of fire extinguisher. So yeah, if you can explain that, like how foam based is effective and CO2 based is not effective for battery related incidents.
Yeah, this is a really surprising technology for me as well. Before Kazam, I am also not aware. So after joining Kazam, I exposed to these lithium-ion fires and fires in EV. And then I did some research on the existing technologies which are efficient to control lithium fires. And then I found that foam with encapsulation agent or water with encapsulation agent is effective, and that can control the fire. So prevention of fire is different game. Prevention of fire is different mechanism, and controlling fire is different mechanism. So prevention of fire totally depends upon the BMS. BMS will take care to prevent the temperature, thermal runaway or temperature growth. Whereas after failure, fire takes place on battery, and that to be controlled. Otherwise, it leads to a disaster and it propagates. So, encapsulation isn't required basically. That is, in terms of fire safety, it is called blanketing. So, here we have to make a blanket over the source, that is lithium ion. So, that blanketing can be effectively done with F500 encapsulation agent. So, that can be used along with the foam or water.
Yeah.
So,
I guess that's an important point for audience and everybody that foam-based encapsulation agent fire extinguishers are more efficient against any battery-related incidents.
yes.
So apart from that, how has been your experience at Kazam? How do you find things? You've had a long career and big companies and now a young startup. So how has that been for you? And yeah.
Yeah, the experience at Kazam, it is like a roller coaster for me. The energy levels, enthusiasm, innovation is very high here in Kazam. Whereas my previous experience, it is already settled environment, everything SOPs, laid out setup. And here we explore, we invent, and we develop. So this is the difference. So that's why I said roller coaster.
Yeah, I mean that's how I guess normal startup life is, but that's again exciting in many times. So cool. I think thanks Sugun for joining
Yeah.
us today, and I hope the audience liked this video. Please subscribe to the channel, guys, if you want to stay updated about everything that is happening in electric vehicle ecosystem in India and across the globe. Thanks Sugun, and
Thank you, Reva. Pleasure having this discussion and session.
yeah,
And hope our viewers like this discussion and they may get benefited with the discussion.
Sure. So cool, and so guys, do subscribe to the channel. I hope you like the video. See you in the next video. Till then, goodbye.